got, Jen? 9. So I think it says the fourth root of 625 is equal to 5. So that's in exponential form, right? So first of all, what power is fourth root, first of all? What power is fourth root? 1 over 4. Okay? So the easy way to do this is, remember, what's the base right here? What's the base? 625 is the base, right? The base always stays the same, so it's going to be log base what? Of what? 5 equals 1/4. What you need to remember is that circle thing I showed you. You go in around in a circle. 625 to the 1/4 is equal to 5. You went from exponential to logarithmic form. That's where you go from. And yes, you asked me at the beginning, am I going to put this up on the, like, am I going to put the general rule at the top of a quiz? No, but that's the first thing you could write down. Like, if you know you're getting quizzed on logarithms, immediately write down the definition of logarithm. Y equals log base a of x is the same thing as a to the y is equal to x. Write it down. Okay, another one. Who's got another one? Hands, anything? Aloud, what would you say? Oh, you got it. Yeah, there's log base x of 125 is equal to. So what are you supposed to do with this? Solve it, right? I think. So this is in logarithmic form, so put it in exponential form. It's going to be, what's the base? So it's going to be x to the equals 125. Now you want to look 125, and what do you think when you see 125? You should think 5. 5 to the third. So this is x to the negative 3 is equal to 5 to the third. There's a lot of different methods. There's no one best method for this one. There's lots of different paths you can take. But at this point, you might guess as to the answer. What do you think the answer is going to be? Well, what do you want to do at this point? Give me one concrete step. What could you do at this point? You don't really like negative exponents, so what could you do?
1 over x.
Yeah, 1 over x to the third, right? And this is 5 to the third over 1. So if you have two things equal to each other, what can you do? So you could write it as 1 equals x to the third, 5 to the third, and then divide both sides by what?
5 to the third.
Yeah, so you have 1 over 5 to the third is equal to x to the third. How do you get rid of a cube? Take the cube root. So this is going to be 1 over 5 is equal to x. That's one path you could take. That's one path you could take. Another path you could take, these are really close. Do they almost have the same power? Yeah. If you want to have the same power, you either want to get the negative out on the left or put the negative in top on the other one. So if you flip a base, what do you do with the exponent? You flip the sign, right? So instead of, for example, on this one right here, instead of x to the negative third, we could make it 1 over x to the third is equal to 5 to the third. If you flip the fraction, what happens to the power? It flips the sign. If you flip the fraction, a over b to the negative 1, what does that equal? B over a. If you flip it over, it takes the sign and makes it the opposite of what it was. So you could do that, but if 1 over x equals 5, if 1 over x to the third equals 5 to the third, what does 1 over x equal? Not
x to the negative 1.
No. Look, if a to the x equals b to the x, what has to be true? A equals b. So if 1 over x to the third equals 5 to the third, what does 1 over x equal? 5. Cross multiply. 1 equals 5x. What does x equal? 1/5. That's another path you could take. There's lots of paths you can take on this. Absolutely. But the key thing is, when you see 125, what should you think? 5 to the third, 5 to the third, 5 to the third. Another way to do this, you want to see just another path you could take? Instead of flipping the left side, you can make 5 to the what? You could make it 1 over 5 to the what power? Negative third. Oh, look, if x to the negative third equals 1/5 to the negative third, what has to be true? Done. Even shorter. There's different ways. Whatever one is more comfortable for you is fine. These are all equally fine. It's 0, right. So we have 1 point, which is 1, 0. What's the next x value you want to plug in? How about 3? Don't plug in. If you plug in 2, you have to answer the question, 3 to what power is 2? And that's nasty, right? We need to pick values that you can fill in nicely. 3 to what power is 3? 1. So we have our next point, 3 comma 1. What's the next value you want to plug in? 9. 3 to what power is 9? So it's 3, 2. So do you have some points here? You absolutely do. So what do you have? You have 1, 0, and then you have 3, 1, and then you have 9, 2. So what does this thing look like? It goes like this, right? And where does it go to the left? Well, we can't plug in 0, but we could plug in a number between 0 and 1. Can you give me a good number to plug in between 0 and 1? 1/3 is a great one. 3 to what power is 1/3? Hold on one sec. -1. -1. So 1/3 comma -1. So it's down here. So what does it look like going to the left? It goes down like that. What do we call in this case, the y-axis acts as a what? You remember what it acts as? It's called it begins with an A. Asymptote. Yeah, very good. Asymptote. Can you cross this? No. Because you have to answer this question. What power do you raise 3 to get 0? There is no power you can raise 3 to get 0. 3 to any power is going to be something other than 0. There's no way to make it 0. Because even 0 to the 0 is 1. So that's how you would graph it. Multiplication. So if you have log base b, see how it's base b here and base b here? The base doesn't change. The base stays the same. If you have the log that is the log of the product of two numbers, that's the same thing as turning it into addition, but with two separate logarithms. So for example, log of 6 times 9 is log of 6 plus log of 9. So in logarithm land, addition and multiplication get linked together. If you have these two right here, log of 6, and you add it to log of 9, you end up with log of actually 54. This is the first thing. This is the first thing. Anybody want to guess as to what they think log of A minus log of B is going to be? They have the same base. So let's say they have log base C. It doesn't really matter. They have to have the same base. What do you think is going to happen when you have subtraction? It's division. So what do you think this is going to equal, Aubrey? Log base C of what?
A.
Yeah. So when you subtract, it turns into division. When you add, it turns into multiplication. When you add, it turns into multiplication. They go both ways. Yes, Mark?
Can you write it log base C of A over log C?
That's a great question, and no, that's one of the clear ways where you end up in another universe. So this is actually one of the things in the book where they say, don't do this. I really don't like writing those things down because you tend to remember it, but I will in this case. Sometimes people like this. They take this, and what do they write? They write log base C of A over log base C of B. This is not, don't do that, okay? I'm not even going to write it down. Don't do it. It's totally not right. You can't just do the log of the top and the log of the bottom. You can't do that.
Because it might equal...
No, it's just totally made up. Yeah, bad things happen, yes.
So would that be log A minus log B if you did that?
Yes, exactly. So if you had log base C of, I don't know, Q over R, what does that equal? Log base C of Q minus log base C of R. Exactly. You can't do one over the other one. Do you understand? This is super important. So these two things right here, these are the basic vowels. These are the basic vowels of manipulating logarithms. What does it mean to cube something? Multiply by itself 3 times. Like this?
Yeah.
Correct? So what does that mean? Yep.
So is it log base 4x
Of x.
Plus log base 4 of x plus log base 4 of x?
Yes, correct. How many of those log base 4s do you have? So what can you do? There are 3 of them. 3 log base 4 of x. Yes, correct. If you have 1 apple and 2 apples and 3 apples, how many? Oh, you have 3 apples. They combine together. But it's really important. When you bust it apart like this, what do you have to put here? Plus and plus. And log and log. Sometimes people will turn this into log base 4 of x plus x plus x. No, you have to put that log in front of it. It doesn't work. I'm giving you the rules for this literally this very simple world we're going to live in, this logarithm world. As long as you stay in the world, it's really straightforward. It's really straightforward. What about this one right here? Do they have the same base?
Yeah.
So does the rule apply?
Yeah.
If they don't have the same base, are you going to learn what you have to do later? Sure. Different bases, you have to do a totally different thing, but you have to make the same bases first. It's like when you add fractions. Can you add fractions without a common denominator? No, it's the same thing here. So what does plus mean? Yep.
So log
Base
7
of
8 times 12.
correct. And you're done. You could multiply to make it log. You could make it log base 7 of 96. Make sure you clearly put the base down below, and when in doubt, put parentheses around this. It's helpful. I really like putting parentheses around things when you're taking the logarithm of them. Otherwise, you might think of it as log base 7 of 8 all times 12. Totally different. totally different. So let's try a different one.
Yeah.
Kids, on this first one right here, you should end up with log base 4 of 4 plus log base 4 of x cubed. So that's going to be 1 plus 3 log base 4 of x. Done. You're done. That's all you need to do. Remember what I told you can do with the power?
Yeah.
Is the 4 being raised to the third power? No. So for the second one here, what does square root mean?
1 over 2 power.
This means the 1 over 2 power. So this is the same thing as log base 7 of m over n to the what power? 1 over 2. What do you do with powers? Nope. Bring it to the front. We're in logarithm land now. 1/2 log base 2 of m over n. But what does division mean?
Subtraction.
So this is going to be 1/2 of log of m minus what? Log of n.
Couldn't you just write it as log base 7 of n minus log base 7 of n?
Where's the 1/2? You have to have the 1/2. Oh, the 7. Sorry, there's the base 7. It's base 7. Sorry, it's base 7. Sorry, base 7. Yep.
So if I have
I say about all these things. Do they have the same base on E?
Yeah.
They have the same base, which is nice. There's one thing you have to take care of first. What's the first thing you have to take care of?
X plus 1 and 2x plus 1.
You could do that, sure, but I really want to get rid of the coefficients first. So what do you do with that 2/3?
Put it over the x.
Yeah, so the exponent. So log base b of x to the...
2/3.
And now what can you do with all of these? Go from left to right. What does this plus mean?
Multiplication.
So it's going to be log base b of x plus 1 times 2x plus 1, right?
Wait, would it be negative 2/3?
I'm not moving the negative. I'm just moving the 2/3. Minus log base. But you're absolutely right, Alex. You could move the negative if you wanted to. I'm not going to, though. So in this case, what does that minus mean now?
Negative 1.
Division.
Division. So it's going to be log base b of what's on top?
X plus
2x plus 1.
over x 2/3.
Done.
Yes. Oh my gosh. There's
Oh, no, seriously.
Done.
There's a
Yes.